Hello, brother. Today our topic are AC inductor circuit. Inductors are do not behave the same resistor, whereas the resistor is a simple oppose the flow of electron through them by dropping a voltage are directly proportional to the current. Inductors oppose the change in the current through them by dropping a voltage directly proportional to the rate of a change of a current in accordance to the Lee's law. This induced voltage is always such a polarity as try to maintain the current as its present value. That is, if the current is increased in the magnitude of an induced voltage will push against the electron flow. If the current is decreasing from a polarity will reserve the pushes within the electron flow oppose the decrease. This opposition to the current or changing in a current is called the reactance or rather than the resistance. Expressed mathematically in a relation between the voltage drop across the inductor rate of a change in a current through the inductor is such as a E is equal to L D1 and D2. Express the D1 and D2 is from a calculating meaning of a rate of a change in the continuous current over a time in a lamp per second. The inductance L is a Henry's. The inductance of a Henry continuous voltage course in a voltage. Sometime you will find the rate of an inductance voltage expressed as a V instead of a E is equal V is equal L and T upon T, but it means they extend the same thing to show the happen with an alternating current. Let's use a simple inductor circuit. Here is a picture to show you. ER is equal I and EL minus IL means after the doping of a material or a voltage then the position will be changed. E2 is equal EL. If a dropping of a voltage is on a 19 angle. Pure inductive circuit, inductive current lagging inductor voltage by a 19 degree. If we are plot the current voltage from very simple circuit, it would look some like this finger below according to the vowel length, and the current is flowing this pure inductive circuit waveforms. And here another one side is showing a time lambda. Remember that the voltage drop across the inductor is a reaction against the change in the current through its. Therefore the instantaneous voltage is a zero. Whenever the instantaneous voltage in the current is a peak, zero changes are a level slopes of a current since sine wave, and the instantaneous voltage is at the peak whatever the instantaneous current is at the maximum, changing the points of a steepest slope of a current wave where is the cross is a zero line. This results in a voltage wave that is a 90 out of a phase with the current wave. Looking for a graph, the voltage wave seems have a head started on the current where the voltage leads the current and the current lagging behind the voltage. Here is a lagging picture of a current and voltage. Current slope is a zero and also voltage slope is a zero. And a dark line is showing a voltage. Current slope voltage is a maximum and voltage is also maximum. Current slope is a zero and maximum voltage means it is in this picture we have clearly shows that the current slope Slope at a full wavelength or a peak load is a 0, and at a minus level this current is a 0. Current lagging through the voltage by a 90 in a pure inductive circuit. Inductor reactance is a position that inductor offers the alternative current during its phase shifted storage and the release of energy in its magnetic field, and reactance is a symbolic by a capital letter X, and it's measured by ohm just like a resistance is a R. Inductive resistance can be calculated using the formula of a XL1 is equal to lambda FLV. The angular velocity of a AC circuit is another way to express its frequency in a unit of electrical radiation per a second instead of a cycle per a second. It is a symbolic by a lowercase of a Greek letter omega. Inductive reactance increase with an increase of a frequency. In other words, the higher of a frequency and the more it's opposed the AC flow of electrons. In this lecture, I have clearly explained about the AC inductor circuit and how it does to be works, and also how the phasor or inductor are inducted in this, and also I will have clearly in these pictures the what is the lagging and the lagging voltage and lagging currents. Here is a dark line is showing that, and also in this the frequencies are the same in the AC inductor circuits. Thanks for watching, and I have also cleared the current slope and the voltage slope at a peak and lagging. Thanks for watching and subscribe my channel. Still yet not subscribed. Thank you. Allah Hafiz.